So I want to remind you how we find the acceleration direction when we've got curved motion rather than straight line motion. And so these are the 5 steps. The first step says we're going to identify what point we're trying to find the acceleration. The second step says that we're going to place a dot before and after the point of interest. Of course, you have to know what kind of motion is happening in order for you to place those dots in the right places. Then you draw V1 and V2 between those dots. And then you redraw V1 and V2 with their tails together. And finally, you draw an arrow from the tip of V1 to the tip of V2. That arrow is going to show you the direction that the acceleration has. Okay, so those are the steps. You can pause this and look at them and read them more carefully if you like. And let's try this on one example. All right, so here we've got a car moving over the hills, and we're going to try and find what the acceleration is at point A. But if we don't know whether the car is speeding up or slowing down, we have no idea how to draw the velocity vectors or to find the acceleration. So again, you're always going to try and remember that acceleration is the change in velocity, so we need to know what the velocity was, what it turned into, so that we can find the acceleration. So in this case, we're going to assume that we're told that the car has increasing speed. Right? I'm not assuming it. A car, it could be slowing down, it could have constant speed. Don't get fooled by the fact that it's going down the hill here. Right? A vehicle can change its speed how it wishes. If it was a ball that was rolling, then that would be a different story because it doesn't have an engine attached to it. But in this case, we're told the car's got increasing speed as it moves through point A. All right, so our steps were find the point of interest, we've done that. Draw a spot before and after based upon the motion. Well, in this case, we've got increasing speed. So sometimes the hardest part is to find the first spot for the point. So if I just pick this as the point before point A, now I can think about the motion and say, well, where should the next dot go? Well, if I drew it closer, that would mean it's slowing down. It went less distance. If I did it the same distance away, that would be constant speed. So in this case, because it's got increasing speed, we know the dot has to be further away from point A than the first dot was. And the only thing I tell people to remember is if I'd drawn this one a lot further away to begin with, and this one would have been somewhere over here, and then you're kind of losing the shape of the motion. So try and keep the dots kind of close to the point that you care about, but not so tiny that you can't see anything. Okay. So now we've drawn the dots, we've drawn the velocity vectors. So there's V1 going from the dot to point A. And here's V2. And remember, these velocity vectors are straight lines. They're not curving, right? They're a velocity vector that we draw from dot to dot. Really, it's the average, but it's a straight line going from one dot to the next. The next step was to take these velocity vectors and redraw them with their tails together. So let me take V2 and draw it down here. And I just look at it and say, that looks okay. I take V1. V1's a lot steeper. I'm going to move it down. All right, so keep the same direction. It's kind of short, though, so it's a bit too long. So I have V1 and V2, and a lot of times people say, well, how do you know whether V1 goes below V2 or above it? Remember, I'm just taking exactly what V1 looked like and moving it down. I'm taking V2, moving it down, and that's why I draw them that way, with their tails together. All right, the last piece, from V1 to V2, then I draw an arrow. And this is really the change in velocity, but that's also the same as the direction of the acceleration vector. And so I can just take this and I can say, this is the direction of the acceleration of point A. So at this point, the acceleration is in this direction. I don't know the length, but I know that's the way it points. Okay, that's it.